So here's the question we're given. With a turboprop engine, jet propulsion cycle, we're given that the aircraft is cruising at an altitude of 9,000 feet, and we're given the conditions for that. We actually don't need these conditions to solve the problem, but we do need the airspeed of the plane. That's 463 kilometers per hour. We need the power that's going from the turbine to the propeller of the plane, and the flow rate of air going through the propeller. What this question is an energy conversion problem, where we have mechanical energy that's coming from the turbine of the engine, and that mechanical energy is going to the propeller and being converted into kinetic energy. So here is the energy balance shown here, where we have the mass flow rate of air through the propeller multiplied by the difference of squares of velocity. That gives us our change in kinetic energy is equal to the power from the turbine. Now we're given that the inlet velocity is 463 kilometers per hour, and if we convert that to meters per second, then that will be equal to 128.61 meters per second. Okay, so now we go and put that information into our energy balance equation. We have that the mass flow rate through the propeller is 800 kilograms per second. The velocity of the exit we do not know. And we know the inlet is 128.61 meters per second. That's all squared divided by 2 is equal to the power from the turbine, which was given as 190 kilowatts. Okay, so we rearranged this to solve for the exit velocity from the propeller. So then that is equal to 1490 kilowatts. I'll write as kilojoules per second divided by 800 kilograms per second, and then we have 1000 We need to convert 1 kilojoule to 1,000 kilograms meters squared per second squared. And then from there, we'll add in the 128.61 meters per second squared divided by 2. So V exit squared divided by 2 is equal to 10,132.7 meters squared per second squared. And then V exit is equal to 142.36 meters per second. If we go back to the energy balance calculation here, this is given a total of 4 marks for 8 marks total in the question. Now that we know the exit velocity from the propeller, we can put that into our equation for thrust, we already know the mass flow rate going through the propeller and the inlet velocity. So if we substitute those values into the equation, we have 800 kilograms per second, we have 142.36 meters per second, subtract 128.61 meters per second, calculate that through, and we end up with 11,000 newtons, or 11.0 kilonewtons. Now that we know our thrust, we can take this value and put it into the equation for propulsive power. The propulsive power is the dot product of the thrust and the velocity of the aircraft, which we are given in the question. So now if we go and calculate that through, we have 11,000 newtons multiplied by 128.61 meters per second, and if we solve this through, we get about 1.14 megawatts of propulsive power. So in terms of a grading, the thrust is given about 2 marks, the propulsive power is given 2 marks,